So these last two problems, I'm actually not going to sketch them, but I just want to go over them for the sake of homework so you're not stuck. Sometimes you are not in factored form, and remember, sketching is so much easier if it's actually in factored form. Okay, so I'm going to show you how to factor it. If I don't give you one of the factors, that means it's an easy factoring problem. So I'll go ahead and show this one. This one you can actually do easily with just the skills you learned last year in factoring. So first thing you want to do is factor out your greatest common factor. I'm actually going to rewrite it in standard form. That's what it's called. So I'm going to go ahead and factor out my greatest common factor. I'm also going to take a negative out. So my greatest common factor is negative x. And if I divide each term by negative x, I get x squared minus 9. X squared minus 9 is a difference of perfect squares, so I'd have x plus 3, x minus 3. So then you would have a function that looks like the previous problems, where you can easily find your x-intercepts and so on, and your y-intercept and whatnot, to go ahead and sketch this. Okay, so likewise, you might have a problem like this where it's written out like this. I tell you what a factor is, but it's in standard form right now. It's not in factored form, which I do want to make a note before I actually show you anything. When it comes to sketching, the only thing that's actually way easier to find, I should say, in factored form is really the x-intercepts. Y-intercepts and end behavior are actually way easier when it's in standard form. Let me just show you that really quick. So in standard form, y-intercept is always going to be the constant number. So for instance, this one, our y-intercept is 0. I don't have to think about it. The end behavior is going to be extra easy because you already have the first term. It's negative x cubed. So I already know the right arrow is going down since the leading coefficient is negative. And the right arrow would go up since the degree is odd, so the arrows have to switch directions. So really the factoring is simply so you can find your x-intercepts. So likewise on this one, without even factoring, I could easily say, well, the y-intercept is the negative 12. And then my end behavior, well, it's x cubed. So my right arrow, since it's a positive x cubed, is up. And since it's an odd degree, that means the arrows need to go opposite directions, so we're going to go down up. So really, finding the remaining factors just helps us find our x-intercepts, which we know one of them, by the way, is going to be negative 4. So last time we learned how to divide. This one's not going to be something you know how to factor. We'll learn next unit how to factor this. So we're going to go ahead and just divide this. So I'm going to go ahead. I know one of my x-intercepts is negative 4. There's one of them, so I know it's going to cross. And let's see what else we have. So let's put our 1, our 2, our negative 11, negative 12, and do synthetic. So drop down the 1. 1 times negative 4 is negative 4. Get negative 2. That's 8. This is negative 3, and this is 12, and 0. This should end up being 0, or else you did something wrong. There should not be a remainder. So this means I actually have the factor x plus 4, because that's one of our factors. Then x squared minus 2x minus 3. I'm going to go ahead and factor this. Should be just basic factoring like you learned last year. So it's x squared, so we have x and x. And we're finding factors of 3 that subtract to give us negative 2. So it'll be a positive 1 and a minus 3. Which means our other x-intercepts are positive 3, and that's also going to cross. And negative 1, and that one's also going to cross. If you forgot to put this x plus 4 down, that's okay, just as long as you factored this x squared minus 2x minus 3 to find the other two factors. That's all we're really doing, just finding the other two factors. And then you'd be able to sketch from there.